So as I said, you're all very welcome. We'll take some time at the end for Q&A. So without further ado, I'll hand over to Eddie to kickstart the presentation.
Thanks, Donald, and welcome everybody to this evening's lecture. And hopefully you will take something away from it. As Donald said, I have 40 years experience, and most people I deal with would probably say it was time he was gone. So with no further ado, I'm just going to get on with this. And what I'm going to try and do this evening is to set the scene from TII's sustainability vision perspective, and try and demonstrate what we're actually doing in terms of sustainability today. So, our vision is set out, it's backed up with a sustainability statement, and we also have an implementation plan. But I'm going to take a very, very narrow focus on our implementation plan, and I'm going to focus on, as I said, what we're doing today in terms of pavement asset management, in terms of material specifications, pavement design and life cycle management, procurement, and education. So in terms of if you Google sustainability definition, you'll see that sustainability consists of fulfilling the needs of current generations without compromising the needs of future generations, while ensuring a balance between economic growth, environmental care, and social well-being. And of course, TII vision for that is, as it says there, it has a vision to lead in the delivery of operation of sustainable transport, enabling our networks to drive inclusive growth, create job opportunities, enhance the well-being of all persons, including vulnerable groups. And I suppose the really, really important bit from the bituminous industry is really to strengthen our resilience to address climate change of our network of payments. And when I talk about industry, I'm talking about the entire community of pavement engineers, be it from the public sector in terms of local authorities or TII or other state agencies and the Department of Transport, but also the suppliers, the producers, the designers in consultancies or in the local authorities. It's not just, so just be wary when I talk about industry, that's what I'm talking about. And really what the whole thing for me is about is, as the graphic shows there, it's sustainable design. But not just design of pavements and design of roads, it's design of the products, design of the systems that we use to design, and it's really bottoms out to responsible materials management. And that's what, getting the design right, getting the production right, getting the product design right, but also getting the implementation in terms of constructing these pavements. So really our vision, as stated in the previous slide, is backed up by a sustainability statement. And when you look at the statement, it covers kind of four headings, looking at corporate leadership, stakeholder and public engagement, evaluation and continual improvement, and strategic management. But it's within this strategic management area that I would like to focus and be, as I say, take a very narrow focus in terms of standards, pavement and minor schemes. And if you look at what's actually printed in our statement under strategic management, you can highlight very quickly within that, in those paragraphs, where the importance is providing guidance and standard for industry. And that's what TII do. It's setting the scene so that, and providing the tools so that industry can respond and they can maximize and optimize their designs within the IAPDM, but also to maximize the amount of materials that can be recycled and can be reused in a sustainable way, and be innovative in producing new materials. So that runs right across, and it's really down to them to achieve efficiency gains in operation and running of network systems. So it's taking all of that and not just one thing. It starts with effective asset management, and it runs into proper and good quality production of materials. So it's really within this stakeholder and public engagement piece where we really kind of engage on a meaningful level with our supply chain operators and try and provide leadership from both sides of the fence. that if it's like a strong army. When you're marching together, you're not fighting. So it's having that leadership and commitment. If you tell me what you're doing, I'll tell you what I'm doing, and in that way, working together and getting everybody working in the same direction and providing materials and tools to work with in a sustainable way. So again, when you look at the vision and the statement, and that's backed up by our uh, sustainability implementation plan, which covers 6 principles. But within the context of this presentation, I'm going to just focus in on principle 4 and 5, which is to deliver end-to-end improvements and this transition to net zero. And it's deliver end-to-end improvements by delivering enhanced whole life cycle costing and value through the impact and influence on stakeholders and partners and suppliers. And then the transition to zero is, well, 5% pretty much of the embodied carbon, of the carbon that's embodied in our network, is really down to materials only. The rest of it is to do with the traffic volumes and the emissions from transport. But it's taking that small piece and doing what we can do, and by doing and producing proper materials and implementing them in a proper and managing them in a proper asset management way, that we can uh, work towards reducing the emissions of transport overall. So that's where I really kind of want to focus this evening. So principle 4 really talks about delivering enhanced whole life cycle value through impact and influence on stakeholders, partners, and suppliers by using fewer resources, using procurement to build total value, and provide guidance to suppliers via standards, work with suppliers and stakeholders to find solutions, and influence the use of sustainable materials and better design. And pretty much all of that is what we're currently doing today. Uh, the only bit that where there is still significant work to do is in the second point there, in terms of procurement and bringing all these systems together in some kind of a sustainable procurement manner. Again, it's responsible materials management right through from the design of the pavement overall, the pavement structure, to incorporating the various products that are in that structure, and then procuring them in a sustainable way. The principles of transition to net zero, again, by decarbonizing our own activities. So within that 5%, it's doing what we can do to try and reduce the carbon within the production of these materials, and re-engineering our systems to optimize material use. So that's the definition of our Irish Analytical Pavement Design Method, and contained within our standard DN PAV 03021. And so it's trying to reduce the amount of material we use, and through better maintenance, increase the lifetime of our assets. So it's about optimizing our design and maximizing our recycling capacity within the industry. So as I said, it's how are we managing our pavement sustainability today from a pavement asset management. I mean, on a daily basis, we're looking at this in TII, and our policy is set out there as in assets will be managed in a sustainable manner through the development, implementation, and maintenance of an asset management approach that is risk-based and data-driven. And that's the entire nub of it. It's risk-based and it's data-driven. It's evidence-based, so that we can respond to issues on the network in a sustainable way. So it's good asset management requires coordinated and optimized planning throughout its life cycle, from development, creation, maintenance, and ultimately disposal. So that's contained within that graphic there. So it's following that right from the very start in designing your asset management system. And our system is designed in such a way, the key to it was setting the system up to define the network in terms of its sub-networks. So we treat our motorways differently than we treat our legacy pavements at subnet 4 and our low volume really low volume national secondary coastal routes, for instance. And that's defined, and I'm not going to read all of that, but it gives you within the presentation, it gives you what a motorway and a dual carriageway, which is fairly obvious. In terms of an engineered pavement, well, these are the national primary routes that maybe have been previously realigned. And if we took the assumption that if they've been realigned, that they would have some kind of an engineered pavement. Urban networks are fairly obvious, and as I say, legacy network 3 and 4 is the sub networks and the low volume. So you can't treat a motorway in the same way as you would treat subnet 4. So that was key to our asset management policy, and in further building our resilience, the resilience of our network to climate change. How is that done? Well, very simple. Simply, we have different levels of expectation from each subnetwork. So it's built around the whole criteria of IRI, root depth, and longitudinal profile variance at 3 meters. So you'll see within subnet 0 within in our network, in our motorway network, you'll see that we expect it, when it's operating in the very good category, it has an IRI of less than 1.5, whereas down at subnet 4, we're happy enough if it's operating less than 3. So that'll give you an example right across the board um, in terms of how we expect our network to perform. And by analyzing the network in this way, we can then have a very targeted approach to what treatment is required, and we can sustainably build a program of works over, say, the current program is from 2022 to 2024, so over a 3-year period, and then we can rerun the system on an annual basis, and we can then refine that program if necessary, and we can pick up any areas that may have failed or have deteriorated quicker than we would have expected. And within the system, then we have treatment costs and benefits and different outcomes from different maintenance treatments. And that's hugely important. So we're getting the whole sustainable approach to the management of our network in the first instance before we even get near developing the various designs or interventions that we possibly need to do. And as part of that, then you will notice if you look at the previous slide there, we have categories from very good to very poor. In the early days of this system, most of our network was in between very poor and fair, and it was very simple to run a program or develop a program because we were operating on a worst first basis. So we wanted to get it from here, from very poor to fair. In more recent years, we're now operating in the category of fair to very good. So we have bigger and higher aspirations, and we want to move the network into the upper levels of that. And that's done through a system of deterioration models that are contained within the system, and that's just an example of one, and it can pick up when the network is performing in terms of its IRI, its root depth, or its LPV3, when it's performing the way we want it to. And if it's not, we can pick up things very quickly and we can intervene at a proper stage, at a sustainable stage where it's not going to cost us too much and we have to end up replacing. We can part replace and or do nothing and operate within this maintenance area here. And then within the system, we have interventions defined as being surface replacement, an overlay, or strengthening or reconstruction. So as I say, that's hugely important in setting the scene and setting our response to managing the network in a proper and sustainable way. The next part of the development of this whole sustainable response to managing the network was to look at our materials. And you will note that our Series 900 was published in 2015, and that was a direct move away from the old British standard recipe approach, where all materials were treated the same, to a more performance-related basis, whereby we set out that we wanted materials to operate in a certain area in terms of voids proportional root depth, and in terms of water sensitivity and stiffness. So that was a move towards European methodologies as opposed to British standard. And this was setting the scene essentially for it to bring in a sustainable design method and treat materials differently. Equally, Series 800 has been published in the recent past, I think maybe July or August. And again, that was a move away from the whole British standard methodology. And now Clause 804 is now known as Unbound Granular Material A. And in terms of its performance, then it's a move away from a recipe type specification to a more performance related. And depending on the design level you pick within the IAPDM, you can then figure out what your design performance is, whether it's compaction or other stiffness methodologies, stiffness modulus, and so on. Again, big changes in terms of our recycling ability, and currently 900 series allows us up to 30%. And we've done trials on the network, and we've determined that that's the correct level given industry capacity and availability of materials. And we're continuing to work and do research in collaboration with certain parts of the industry to look at this 30% and to maximize that as far as we possibly can. Everybody knows that if you're adding wrap into your mix from a hot feed perspective, that you could maybe add more than that. And equally, you can maximize that up to maybe possibly 40% in terms of a cold feed operation. Again, with 800 series, we're allowing the use of recycling depending on which design level you choose. And in terms of restrictions, that's all outlined within the 800 series that was recently published. So again, how are we managing our materials, our pavement design as of today? What are people doing? And they're actively engaged in sustainable design, given that we published our IAPDM last month and its associated standard. And what we moved was away from a recipe approach, an empirical approach to a mechanistic empirical design. So we're looking at our models, take into consideration the climates, take in importantly the material properties, again going back to series 900, taking into that performance related properties, taking into consideration traffic. It all goes into this mechanistic analysis, and then outcomes to predicted performance. And this is the critical piece of design software or standard that is required, in that now we can take industry's innovation, or we can take the various wrap contents or recycled aggregate contents that we want to use within mixes, and we can directly compare their performance to a standardized mix. And that is a game changer in terms of sustainability. And again, that was published and is available. And I think I've currently probably about 30 people signed up across our web portal and have access to use that design approach. And in fact, of course, the other old method, HT2526, is now withdrawn. And this is the standardized method of design from here on out. So this is all stuff that is happening on a daily basis as of now, which really demonstrates that the bituminous industry is behaving in as sustainable a way as possible based on current standards. Again, the other critical piece that is not quite delivered yet is the whole life cycle management tool that will go hand in hand with our IAPDM. And what we're looking at is developing environmental product declarations, which are the key to this whole environmental and sustainable piece, in that you will be able to use the IAPDM to come up with various design options in terms of design option 1, 2, and so on. And then it's taking the EPD and life cycle analysis for initially a product and then subsequently project, and putting that into a life cycle management tool that is linked with our IAPDM, and then producing an optimal design. So that's where that's the current, that's the main piece of work that's going on, and currently we have delivered to our industry working group, in a spirit of a detailed spirit of collaboration, the first draft of our product category rules, complementary product category rules in accordance with 15 104, for the product stage from A1 to A3. We hope to expand that into the construction stage and then on into C and D. This is the very difficult part here, the user stage, and that will be coming on later on when, and it's really a matter of availability of data. So that is the major piece of work from a bituminous pavement design sustainability piece that's left to do. The rest of it is stuff that we're doing on a daily basis. Associated with that piece then is the sustainable procurement. And what's on screen there at the moment is all of the high level government stuff. But really what's required at ground level is an inclusion of a clear and verifiable environmental criteria, and that's where this the environmental product declarations will come in, particularly to start off with, in terms of the production stage and then the construction phase and then on into the rest of it. So that's ongoing piece of work at the moment, and an update on that is, as I said, the closing date for comments from industry was on Friday last. They've been very good to respond. We'll analyze those comments and we'll adjust if necessary the documents, or certainly clarify and explain, and it would be certainly my hope to have contained within our Series 900 a requirement for industry to produce an environmental product declaration as part of, similar to a CE mark, as part of the product specification, and then ultimately working that through to project, and then ultimately into the procurement piece, which is probably a little bit further down the line. In terms of education then, you will see that Engineers Ireland run a course which was developed by TII in association with our technical partners, Arab. And this is the education piece. It's, as I say, runs from Engineers Ireland and is accredited by TU Dublin at 5 ECTSs, so essentially one module of a master's. And at the very core of this piece is IAPDM and lifecycle management, and then really this course is everything you wanted to know about pavements, but we're afraid to ask, to take a phrase from a well-known movie. So really, if you haven't signed up to this, I would recommend it. And the next course is running in January, I think on around the 22nd or so, the last week in January. And we run it about twice a year. So I think that pretty much does it from me. And I think there'll be questions later if you want. But if anybody wants to contact me directly, feel free. And that's my email address. Thanks very much.
So my name is Alan Anderson. I'm a project engineer with Colas Ireland. Today I'm going to talk you through some of the materials we use, I suppose, in pavements. I'm going to talk about some of the low carbon options. So again, I'm from Colas. So any of you that don't know, Colas is an abbreviation of cold asphalt. So that's kind of some of the topics I'm going to talk about. So what I'm going to do is go through some of the processes that are being used and are being used on TII on the network, and then some of the other processes, then maintenance tools to that can be used. So again, probably I'm going to talk a little bit more about the materials, in on the basics, and hopefully that you all get something out of it. So I'm going to start from the beginning, I suppose. What is a hot mix asphalt? So on screen you can see a picture of an asphalt plant. So when we're talking about asphalt, it's really different sizes of aggregate, the different sizes of aggregate mixed with a bitumen. So as you can see here in the plant, the different fractions of aggregate. All of this aggregate that goes into a hot mix asphalt, in the name, it has to be heated up to 180 to 190 degrees. The bitumen is at 160 degrees. So it's mixed together and mixed through the plant there, depending on what type of material you're looking for. We're talking about our asphalt concretes, our hot rolled asphalts, and our SMAs. And they're brought to the site and laid at a higher temperature. So again, I suppose this is when we're talking about the product, why can't we just do these layers of hot mix asphalt and leave it forever? Nothing really lasts forever. So again, the weather, aging of bitumen cause the product to break down. So then, as Eddie mentioned as well, we want to look at some maintenance techniques and other ways of doing that, of making sure that we have a more carbon-friendly product. So again, that's just brought to site, laid hot by a paver, and then compacted to get your required densities with rollers. So some of the alternatives are work in conjunction with a hot mix. We have two options, I suppose. One is a warm mix asphalt. So again, this is the same typical, you're doing your hot mix asphalts and you're adding either a wax, foam bitumen, or a chemical surfactant to reduce the temperatures of that hot mix. So as can be seen there by the slide on screen, it can be reduced by up to 35 degrees for mixing and laying temperatures. So just an overview there of warm mix asphalt that's used in the world. So as we see there, our highest percentage, probably 19%, is used in America. We're probably at about 3% in Europe. The reasons for its so high use in the States is for transport. So again, you have more workability with the warm mix there. It gives you greater workability when you're adding the chemicals there to use it. There is some countries, you see Norway there, we're 23%, and the Netherlands. So again, as Eddie mentioned, some of these countries got it to procurement, so they are given an added value to have a reduced carbon product on the market. And some of these countries might be slightly ahead of ourselves. So again, until we get that, the products being specified in procurement, that we won't be, it'll be down to price as for products. But again, it's just worth knowing that the warm mix asphalt is a product that's in the Irish market, is part of the TII specs that he talked about, and is a proven product on the market. Again, here, I suppose just a few bit information on warm mix that we've done within Colas. So we can, as I said, you can reduce it by 35 degrees. It does reduce the VOCs on site. It can reduce the mixing by 15 to 20% in the fuel usage. And then again, we can have a saving of 16 tons of CO2 per meters cubed, per kilometer, when compared to 22 millimeters of asphalt layer, 7 meters wide of a pavement. So again, I'll show you where I get them figures from now in a second, but the carbon footprint of this in Ireland is about 4 million tons for asphalt. And if we use warm mix, we could reduce it by over 30,000 tons of carbon per annum. So again, something to note there. So where am I getting these figures? So this SEV tool is an environmental tool, and it was designed by the European Commission. It's used in France, Hungary, Spain, Germany, and us as Colas, we have access to it. It's an environmental tool, so it gets your raw materials, your manufacturing practices, your transport. It puts it into the tool, and it gives you your outcomes there of your environmental. So again, the greenhouse gas emissions or your carbon footprint. So again, that's a tool that's used across Europe at the minute. And for this presentation purposes, I have put in some figures. So what that tool does, it gives the contractors or the people doing the work an option to use an environmental comparison between different processes, and some of them that I'm going to talk about now. And then it gives you, it can show your benefits by using this process on a project. So the second part, when I'm talking about hot mixes, is the use of reclaimed asphalt, and Eddie showed it in his slide. I suppose the most important one about this is the last sentence, that the reclaimed asphalt should not be allowed to use in surface courses, but you can use up to 30% reclaimed asphalt in your hot mixes for base and binder courses. So again, just something to stick with there. So What are we talking about? We're talking about reclaimed asphalt. So it is asphalt that's already on the road. It's planed up and it's brought to a storage facility or a facility like the one on site here. So in the hot mix industry, you have to have the asphalt under cover here. So you want to keep the moisture out of the asphalt for when you're putting it into your hot mix. And as I say, 30% can be used. So again, I just have a slide here. It's from the Irish Asphalt Pavement Producers Association, IAPA, and thanks to Edmund Hegarty, who's actually on the talk tonight. So again, there is 42 asphalt plants around Ireland, and 17 of the plants have a facility to use reuse reclaimed asphalt. So again, if for somebody on the call that mightn't be aware, what is the industry doing for asphalt? So as you can see, they're quite spread around the Republic of Ireland. They are able to use reclaimed asphalt in the process, and they're doing up to 30%. There's actually a project that Eddie is involved with, the TII are involved with, where they're doing trials on using up to 60% reclaimed asphalt in the product. So again, something that I don't know an awful lot about, but I said I'd just mention it. So then when we're talking, what I'd be based in is cold mix asphalt. So what's the difference then when we're talking compared to cold mix asphalt? Really the main difference is we're not heating the aggregates, and we're not using a hot bitumen binder. We're using a bitumen emulsion, which is typically between 30 and 80 degrees. Again, similar setup. You're using your different fractions of aggregate, mixing it with emulsion in a mixer bin, and then conveyor it onto site. But again, so it's a cold process. This is what it looks like on the road. So again, your base binder layers can be used for. What are the advantages, I suppose, when you're talking about it? It's a softer residual binder, so you have less binder aging, more flexible pavement, and less fatigue to crack in its lifetime. So this is a site, again, as I say, most of these products I'm talking about are tried and tested. This one was on the M8 here down in Fermoy. The job was constructed in 1989. So again, as you can see, that's a picture of the site there of the wrap, and we used 20% of a corrective aggregate. So again, I'm just going to show you there the laying of that contract. So again, this was done in association with the Department of Transport, with the TII, the Department of Transport, and Monaghan County Council. So again, as you see it going down there. So the process was laid in 2 layers. This was the base and binder of the road, and then we surface dress the road afterwards. So it does need a surface dressing. This is typically the setup of the plant. So again, we have our recycled in the foreground here. We brought in a plant from Virkin there. So that's a mobile plant on an Arctic lorry. So a very small plant can be brought out. You're mixing it with a bitumen emulsion. We did about 5%. We added 1% cement, and then, as I said, 20% of the corrective aggregate. So that's it being loaded into the lorry there for the road. So I'd just actually like to mention one of my colleagues, Alan Kavanagh and Kevin West from Monaghan County Council, are doing a specific talk on this project with IAT tomorrow. It's in Enfield, so if any are available to go down to that, it will be a good talk. So that's just on the use of coal mix with recycled asphalt. So again, then we did a specific one again. So this was using the SEV tool again for this project. The project was designed by ARP, so we did have a hot mix option and a coal mix for this exact site, and we found that we had 40.8% savings in our carbon. So that equated to 44 tons of carbon saved. So quite significant there for that project. And I'm going to go back onto in situ site recycling. So as Eddie said, we're not always talking about motorways and dual carriageways. We're talking about the low volume traffic roads. This is just another option for the engineers out there for when you're doing your pavements. So again, this is what we call our in situ recycling. I suppose terminology mightn't be correct. It's more of a reuse. We are reusing the material into the pavement, and it is in situ, so it's not leaving the site to be mixed like the other 2 processes I was talking about. So again, it's an engineered pavement. So again, we're adding our bitumen emulsion, and we're adding water again to get your moisture content. And if you are doing that and you're when we are designing an in-situ recycling, we might need corrective aggregates or we might need cement. So this can be spread on the road in front of the train there, and it's mixed up all together with the emulsion. And then we have a grader that grades out and gives you a profile of the road, and then we compact it again with steel drum and rubber tire roller. So again, that's followed up by a surface dress and something similar to the cold mix I have. So again, another option there for recycling. So where is this suitable? I suppose if you're structural or failures or distressed, as you see something like this on the road here, we have cracking, very variable road, a lot of pothole in your surface is gone there, so something edge deformation. So again, and there you see some structural damage there again. So what we do there is bring in the machine. It has a drum on it where planes the road effectively. It adds the bitumen emulsion to the water, and it's laid on the road afterwards. So again, that's the train there again with the emulsion tanker and the water. So this is again widely used on more local and secondary roads throughout Ireland. A tried and tested material, reduces your carbon footprint by up to 50%. And again, there you can see that some of the savings again when you compare it with alternative methods of bringing new material to the site. Again, another one for the same type of roads, we're talking about local and regional roads, is surface dressing. So again, what is a surface dressing? So it's thin layers of bitumen emulsion followed by aggregate. It increases the skid resistance of the road. It seals the road from moisture getting in and causing the potholes and degradation of your underground layers. It's a cost-effective, durable surface. And again, it can save you up to 53% when you're comparing it to a 50 mil thick overlay. So again, another process that's widely used across the island of Ireland, but again, it might not come to everyone's mind that it is a carbon saving product when you compare it to alternative methods. I suppose some other options that Eddie's mentioned maybe is materials and material management. So again, we have a very good source of aggregate in Ireland. We're using high PSV, we're using bigger sizes of aggregate. It's something maybe to think about, using smaller sizes of aggregate on access tracks and lower volume traffic roads. So again, there is areas where we can be more environmentally friendly and saving on cost effective. So I'm just going to go back to a pavement preservation technique here. So again, this would be for our hot mixes. So again, applies a protective layer to the surface of asphalt and prolongs its life. So this product here is just really a bitumen binder sprayed on top of your HRAs or your SMAs. Again, it has a rejuvenating oil in there, and it brings a softening point back to the binder, and it can extend the pavement life for up to 6 years. So just to talk you through the process again, it's a binder that's sprayed on the thin layer on the surface of the asphalt. This is really the best picture I have on it. So as you can see there, the binder is penetrating down there. You can see the air bubbles coming back up. So it is penetrating down into the layer of that hot rolled asphalt there and coating the aggregates. We have a high PSV dust that's supplied there again. It gives it back the mortar there. So that's what you're looking for, your mask back in your hot rolled asphalt. And then after the track, you can see it's back in black. So again, that process, we do a lot of it on the M1 there. So on that project, they were noticing that they had a lot of the bigger chips coming out of their hot rolled asphalt, and it was accumulating on the hard shoulder. They used to weigh the sweeper to see how much was coming off it. After this process was done, we reweighed it, and they noticed that they were having very little plucking of the bigger aggregate. So again, a good option there is pavement preservation techniques, and again, they are specified in some of the TII documents there. And there is as Eddie said, there is a place there to use innovative techniques and different products to maintain your network. So again, it can be a 95% saving in carbon when you compare it to an overlay. On the flip side then again is retexturing. So maybe again, what Eddie was talking about, we have kind of brought up the standards of our pavement. The TII have good documents there, and a lot of the contractors have really increased their products and what they're given to the market. But in certain times you can get a place where you have texture problems, and what that could mean is going back and milling out the product you put down and overlaying it again, making sure you get it right. But or alternatively, you can use the high velocity impact shot blaster here we see on screen and just retexture that pavement. So again, without another very environmentally friendly way of if it will work is getting the texture back in the surface. You're not bringing new materials, you're not wasting material again just to get your texture in there. This is an option. Again, where we see a lot of this is maybe on our surface stress roads, where the material is in the road, the binder's in the road, the aggregate is in the road, but we do get this with the increased temperatures. We are seeing the roads boiling up or fatten up, as we call it here, and losing their texture. So as you see there, this project was a low texture there, 0.43. We did a water jetting system, which this was exact same location again, so you can see the texture was renewed there. And we got it back to a 1.83 millimeters of texture there on that road. So again, another option there, as I say, we're talking about saving carbon, not overusing materials, bringing them to the site again. This can be an option in certain cases. And as I say, we want to keep the water out of the pavement if we can at all. This is just, as I say, probably poor practice on joints. Again, with the new 900 series and that, we have brought up the standard of joints and painting the joints and making sure we're keeping the water out of there. But in areas where you do get joints like this, and the other option is to mill it out and pave it again. As you see here, they don't look that big, the joints, but when you get the water in there, freeze thaw action, you break out your pavement. So again, here is an option, and the AMPAV 0659 is a TII document there that specifies crack seals and joint repair. So there are a number of systems out there. Typically what it is a bitumen binder, as you see here, fills up the void there, the crack, and then there's an overband in there with a high PSV bauxite material in it to give you your skid resistance. So again, a simple technique. It can be a huge saving in carbon and cost as well, if this material will work in your joints and prolong the life of your pavement. Another process here, a cold mix microsurfacing. So again, this is a cold mix or a slurry seal. It is specified in 0.71 of the TII 900 series again. So it is a product that can be used. What are the advantages of it? So again, it's a cold mix, all mixed on the machine there. It gives thin layers of asphalt, so you don't have to do any work with your curbs or your iron work. So again, it gives a thin layer of asphalt there, a high PSV in it. So again, typically what we're looking for is a before here, where we might have trenches or maybe pothole in our overlay. So again, a microsurfacing might be an option there again. So just another process where when we're comparing it with the thin layer asphalts, we can save carbon again. So that's typically what at the end of my product. So dealing with climate change, I suppose, is a complex problem. The principal contributors, as I said earlier on, is our materials, so the bitumen and the stone. One way to reduce emission in the sector is reduce the need of the amount of bitumen we use and stone that we're using, and choosing the correct material, I suppose, ensuring, as Eddie alluded to, that it's constructed to a high standard, and then after that ensure we have a good maintenance routine, as Eddie talked about in the life cycle analysis. Use of low carbon treatments to prolong the pavement lives, also another option, and the use of low energy pavement materials and methods where pavements need renewal and replacement. So again, some things to think about there. Thank you very much for your attention. That's my presentation, and I look forward to any questions. Thank you.
That was great. Okay, so what we'll do is we'll throw it open to the floor. I'm just going to jump into the Q&A session here. Okay, so a few good questions here. So Tom Casey has asked the question: how will life cycle risk equalization be addressed in the procurement process?
Good man, Tom. That's a good question. Come back, Tom, all is forgiven, I would say. No, yeah, I think maybe one thing I maybe didn't really highlight as much is that while sustainability and innovation is important, durability is key and king. So really what I think what we need to do in analyzing any of those risks, what we're after is and what I tried to demonstrate was it's a kind of an end-to-end system and a process where it starts with asset management and it ends up with life cycle and procurement, and it's managing all of those risks and detailing them and dealing with them as we go through that process, where they might occur throughout that process. But ultimately, the whole EPD element is just starting off, and that will play into the whole procurement process. And until we get it into contract documents where there is give and take, where the contractor can get scored, get high scores within a procurement process for his economic and as well as his environmental performance. That's the payback, and that's what will drive the industry towards an ultimate circular economy.
Thanks, Eddie. And sorry, I skipped past Dinos Pakolas as dialing in from Greece, and he's asked the question: what proportion, if any, of consideration is given to the price fluctuations of bitumen prices during the design process?
Well, again, life cycle analysis is where it's at. So it's the price of the pavement today discounted into the future and taking into consideration all of the risks that Tom is alluding to there along the way and trying to cost those out. So that we end up with a durable pavement at the end of it. So yes, cost should be and will be taken into consideration throughout the life cycle management tool when it's fully developed. But it's a staged process, starting off with the development and getting the whole EPD and getting everybody, all the producers and suppliers producing EPDs off a level playing pitch so that they're comparable across the board. And when that happens, then we can attach costs and prices and so on and so forth into the future.
Okay. Third question from Daniel Cagney: has the use of soil stabilization with a lime or cement binder been considered for use in the capping layers to reduce material imports?
No, not in the current Series 800, but Series 600 is just started off in its development, and again, all of those processes will be looked at for incorporation and if they're useful. So it's about kind of again sustainability and introducing. If you can improve a subgrade as opposed to digging it out and replacing it with a capping layer, well, then that's what we should do. Equally, we should be able to improve materials right throughout the pavement structure from subgrade right up by incorporating different materials. For instance, as Alan pointed out, the whole surface preservative, that was a trial that we completed in association with COLAS and a very successful trial. So that's something that we need to incorporate, those processes, rather than replacing a surface course. Let's see if we can rejuvenate it and get another couple of years. Again, it's down to how durable is the treatment versus how the overall cost of it. And does it present, again, going back to Tom's point, does it present any risk to the driver across that? So as I say, that trial in surface course rejuvenators was very successful, and that's something that's on my list of things to do, is to incorporate that process into Series 900.
Very good. Next question is from Brian Braniff. For in-situ recycling, what's the minimum depth of existing blacktop required to make it work?
Well, how long is a piece of string? It was like the guy rang me up one day from a local authority and says, how much cement do I need to add? Well, it depends on your traffic volumes, and it depends on your design process, and it depends on a whole raft of stuff. And again, this is where IPDM is key, because it now tells me by designing my pavement using the traffic volume, or even using a theoretical stiffness that I want to achieve, that gives industry then a set of criteria to be able to develop a product with the whatever bituminous emulsions or whatever materials they need to add, whatever additives they need to put in to maximize and optimize that strength and that will determine the depth of my pavement. So again, as I say, IAPDM is key here, that I can compare. I could put in a standard, 40, 60, 100 surface course based binder using standard materials, and then I can put in these innovative materials and cold mix materials, and based on their stiffnesses and their performance in the field, I can compare that directly and then determine which is the better. And again, going back to the previous question, I can cost all of that, and I can decide what's the most sustainable cost. And going back to Tom's point, what's the risk involved in its durability? Might be cheap and cheerful and environmentally friendly to do a cold mix, but I'm only going to get 5 or 10 years out of it. Whereas it might be much more expensive to do a complete hot mix, less environmentally friendly, but more durable. What's the payoff? What's the balance that I need to strike across that? IAPDM is where it's at.
Okay. Next question is from Tom again there. Is there an Irish process that can be used to choose the optimal solution from all of the options covered in Alan's presentation for a specific project?
You'd have to say that again.
So I think in terms of all the options covered in Alan's presentation for a specific project, is there an Irish process that can be used to choose the optimal solution, I suppose, whether it be kind of the Pentac approach, or whether it be the use of wrap, or a more invasive? Yeah.
So again, it's the starting point here is IAPDM. So all of the materials can be compared now, as I said earlier, to a standard design. And so I can now bring into that, what depth of new materials am I using? Is there a reduction in depth? Is there an increase in depth in terms of cold materials? Are they suitable for overlay? Do I have to do them inlay? So all of these options I can compare. And then when we move, and I will have early next year EPDs for hot mixes, and we will move then throughout the year for EPDs for cold mixes, EPDs for hydraulically bound, and so on. Then we can compare them all environmentally on a same level playing pitch, and then we can look at the costs at any one particular time. And then ultimately, when a life cycle management tool is in process, we can then, similar to the PPP process, we can then discount them across a number of years and come up with the best option, the most cost effective, environmentally friendly, and so on. And that's when I say we're looking at an end-to-end process, starting with asset management and setting out how we want our network to perform, identifying when it's most optimum to intervene, and then determining what's the intervention, what type of intervention is most suitable. Is it a motorway I'm dealing with, or is it a legacy subnet 4? Is it in a flood area? What's its resilience in terms of climate change? All of that has been currently built. So what we're talking about today, both Alan and I, is sustainability in what we're actually doing today. What everybody in this community has been doing today at their desk. They've been looking at asset management. They've been looking at developing and designing materials. They've been looking at designing materials for a particular scheme here, there, everywhere throughout the country that's going to be implemented in this year. So this is all work that's actually ongoing. And the only gap in it at the moment is that level playing pitch for environmental product declarations, which we're starting and we're well into at this stage.
Yeah, very good. I'm conscious that Alan seems to be getting away very lightly, so I'm going to direct the next question at him. James Loney is asking, what surface age is the best time to apply the rejuvenating oil, or should we wait till we see signs of raveling? Is the rejuvenating oil suitable for roundabouts?
Good question, James. Yeah, I'd say it's kind of case by case. We do it anyway, and if it is kind of when we are seeing a bit of aging. But again, as I say, it would be case by case. I think it is suitable for roundabouts. I think it's just the one that Eddie and myself spoke about was on the M1, so it was holding the bigger chips in there. We put back a mastic, and it just prolongs that life. Any of the bigger chips you're losing, they're gone out of it, but it's about holding what you have there. I hope that answered that question. If I can just go back to Brian's in situ, the IAT actually do a book there. I don't know if you can see that well, but it is the best practices for cold in situ recycling. So again, we do probably probably between 100 mil and 150 mil of the recycling, and then it does be surface dressed on lower volume roads. So again, I hope that answered that question. And for Brian there and James.
Okay.
Just Donald, just to jump in to James, to answer again, we monitor our network, the National Road Network, on an annual basis using automated machines to do our network survey. So we know the amount of raveling, we know the amount of cracking across the network. So it's really goes back to sustainability in the bituminous industry. It's TII identifying, based on their asset management processes, identifying the correct what's happening on a particular pavement, understanding what the root cause of that, and applying the correct process or treatment that's most environmentally friendly. And that's what we do on a daily basis.
Okay, very good. Thanks for that, guys. Moving on then, second last question from Dinos Pacolis. What is the total accumulated energy between emulsions? As well, what is the cost comparison between the different alternatives in comparison with hot mix asphalt?
Well, I can have a go at that to start off with, because I'm tired saying it now, lads. It's IAPDM. We can determine what's the most appropriate treatment, and that's your starting point. It's using proper sustainable management of materials, and it's understanding what the root cause of the problem is and applying the correct and most durable treatment.
Okay, thanks, Eddie. Okay, well, the last question there for me in sports, are we looking at removing bitumen products completely? And what are the timelines? What are the alternatives?
I doubt it. I doubt it. There's a global industry there, and you can look at the. Certainly, I think what we need to do, and I've been using this phrase, and I don't know where I stole it from, was we're trying to convert our network into a linear quarry, so that we can recycle and reuse as much as we possibly can across the network. So to introduce other products other than bituminous products into that could potentially wreck that process. So it's not turning our, as somebody said to me, our network into a linear landfill site. It's maintaining it as a linear quarry, because not all materials, plastics, all these other that people are knocking on our doors about, they're all different. They don't all perform the same, and they will prevent us from recycling, because currently asphalt is 100% recyclable.
Okay, thanks for that. That's an interesting term I hadn't come across before, linear quarry. Okay, very good.
Yeah.
Okay, we should look at that's great. Really appreciate the questions from the audience. Some very thought-provoking commentary there as well in terms of the responsive feedback. One bit of housekeeping I did neglect to mention at the start of this lecture was just that we are co-hosting this event with the Roads and Transport Society. So we've got a very good attendance at this lecture. It's just to acknowledge our RTS colleagues, because it's a great way for us to broaden the reach of the potential attendees and basically get more people involved and interested and engaged in what's been presented. So without much more, then I think what I'll do is we've an old tradition when we have our lectures in-house that we would call upon someone in the sphere of influence of the presenters to give a vote of thanks. So I'll ask Jim Campbell of Colas to come in and give the vote of thanks for the speakers. Jim, you're on mute there.
Yep. Could I just congratulate Engineers Ireland and the Road and Transport Society for putting together a very stimulating and very interesting discussion, and also congratulate the two presenters, both of whom I know quite well, and I'm scarcely surprised at the quality of their presentations. And very briefly, I've taken two phrases which I would ask people listening to take on board. And one is responsible material management. And I think that has to be critical to what we are doing now and into the future. But also, this talk has been about sustainability, but not really discussing what we might consider doing into the future, but sustainability in what we are doing today and can do today. And I think that's where we need to be starting. So again, congratulations to everybody involved. Thank you very much. But unfortunately, I don't think we'll be able to hear the applause. Thank you.